Hey everyone, you're watching the Inside Out BIM, and today we're taking on vectors in Dynamo. I'm going to be using Revit 2023. All nodes are compatible with previous versions. I just dig the UI of this one. But before jumping in to Dynamo, let's understand when we use vectors the most when it comes to working in Revit. So here I have a simple element, just a furniture, just a point-based family. So when I want to move this, so actually vectors help us move the elements. That is like the most simplest like usage of vectors, especially when it comes to our mundane work. So for example, let's represent this movement by the line. So we go here, here, and eventually we can grab the element and move it right here. So basically that can be represented as a vector, but let's understand some things that are vitally important to be aware of. So the first thing that we need to know is to how we can actually create vectors. So let's go to the geometry. As you can see here, we have like sub subfolders, let's say. But let's go with the abstract one because abstract one, this is where the vector is because it's not visible. So everything under abstract is invisible. So that is something you cannot see, and we would need to come up with the option to visualize it. So let's go to vectors. Here under plus sign are located nodes that are responsible for creating your vectors. Now, this is what is really interesting right now. As you can see, we have like three options, like by coordinates again, but here we can specify whether it's normalized or not. We will talk about it. By 2 points, and here, as you can see, we have uh, the ones that don't have any input, like these ones. They don't have any input, you just have this vector. So let's analyze the ones that are coming by default and what that vector is actually. So as you can see here, you can read some information about it. So you have some point, right, with the coordinates like x equals to 1, y equals to 0, and z equals to 0. And you have length, and that's it. So even when you create vector by 2 points, and you may think that your vector actually has 2 points, it doesn't. Your vector consists of 1 point and it knows about its length. So even if I were to uh, grab the Dynamo primer, here it's a cool visualization of this. I'm gonna show you this, but actually here we can see that our beginning is always the beginning of our global coordinate system. So let's kind of see what that is in Revit. So if I kind of collapse Dynamo, let's go to 3D, and I'm gonna go to Visibility Graphics to Site, and I'm gonna turn on the internal origin so we can see the origin. As you can see, Revit has its origin, its global coordinate system. That is the coordinate system that we cannot change. That is immutable. And as you can see, even if you go like from the top, we can see that the right one is our X direction. The green one is the Y direction. And the blue one is the Z direction. So basically in Revit, we have this global coordinate system that is immutable, that we cannot change. And this coordinate system represents by three vectors, vectors to the X, vector to the y, and vector to the z. So here we can see three vectors. And why they have only like 1 point? Because their start point is always, its start point always goes from the beginning of the coordinate system. So from this one. So if I again would want to display you the vector of this element. So let's copy this back even here. So to move this element here, our vector will be actually represented like this because it always starts from the origin. So actually with this reference planes, I just kind of mark the beginning of my coordinate system. So that will be the representation of the vectors. It always starts from the beginning of my coordinate system, of the global coordinate system in Revit. And of course, we know the length of this because I know the direction here, but I could change the length, right? And that would be not to here, but to somewhere here. So let's kind of try to do something in Dynamo like that. So let's create just a simple geometry, um, like a sphere, for example. So let's go to solid. Here we have a sphere by center point and radius, and we kind of have uh, like let's change this center radius to this center point to somewhere over here or maybe even here. So let's create a point by coordinates. So for the time being, I'm just gonna say that on my y, let's add, for example, oops, that on my y, let's add 5 and connect this start point. So that will be like the beginning of my sphere. And let's move it, right? So we know that we have our modifiers, geometry. Here we have a lot of different stuff, but here we have the option to translate it. So translate geometry in the given direction by the vector length. So here we can pass the geometry and move this. So as you can see, when you hover over direction, it says you that that is a vector. So by moving this one, we can actually analyze it. So as you can see, it tells me that my endpoint, and let's actually visualize this, right? Let's go to abstract, vector, and here you have an option as point. So you can, here under plus sign, you can create your vectors, but under Thunder, you can modify it, right? So you can do some modification, you can do add, you can grab the angle between vectors. We're gonna look over a lot of options, but also you can visualize this as point. So what happens here, as you can see, the point is right over here. Its point actually is this one, x equals to 1, y equals to 0, and z equals to 0, right? That is our y direction. It equals to 0, so it's going to be here. Our z direction is the one that goes up, also equals to 0. And our x equals to 1, so that will be here, 1. Right? So if I go like here, if I select this point and actually go here, we can see that it's like 1 here. So what happens when I grab my sphere and I move this in this direction? Of course, we don't want to grab the point, we want to grab the vector. As you can see, it just moved here. Let's gonna turn off the preview of this. It kind of moved just one to this side. As you can see, this vector is right over here. If you want to see the real representation of the vector, we can create actually a line. So here under curves, we can go to line and we have line by start point, direction, and length. So our start point is always going to be the origin. So we can go to points, point, and here we have origin. So that is like your origin of the coordinate system in Revit. You can go with the direction, vector direction, and you can grab the length of your vector. So I go back to abstract, vector, and here I can notes under question mark usually will be like grab the information of the existing element. So go length. So if I do something like this will visualize the vector. As you can see, that is what your vector actually looks like. So if I want to change its length. So now it's normalized. What does it mean, a normalized vector? That means that its length equals to 1. So if I go here, we can see that the length equals to 1. So what have we understand so far? That vector even though we kind of think that it consists of 2 points of start and end because we're kind of defining the where to move, but actually not. It contains only 1 point because the start point always goes from the beginning of our coordinate system. And we also now know that the normalized vector is the vector that has a length of 1. But how can we change it? So here in vectors, we have an option to scale. So when you scale, again, let's scale this to 5. Let's see what kind of information we have right now. Our x equals to 5 right now, and our length is also 5. So what we can do here is that let's visualize, let's delete this one vector actually. And instead of that, I'm gonna connect this one. Of course, I've deleted the previous one, but I wanted it to be connected here. So actually, I'm gonna connect it. So this one, actually, we don't need to visualize this as point anymore. So vector here and vector here. I'm holding the control so I can connect multiple ones. So now this is the real representation of my vector. And if I connect it here, as you can see, that was moved right over here. So what we can understand, what we can comprehend that the vector represents by 1 point because the beginning is always starting from the beginning, from the origin of your coordinate system, of your global coordinate system. Well, that's not that complicated. Let's create our own vector. So as you can see, we have an option to create it by 2 points. Maybe let's even go to Revit and create a line. For example, like here we have a line. Let's create it, and by changing it, we will actually move this element that we have here. So for the time being, I'm not gonna move it anywhere, right? I'm gonna just go with the select model element from Revit, right? And I'm gonna pick this line. From each Revit element, we can get its geometry. So we can go element.geometry. I think that we can get from this one. Yeah, line. As you can see, we have the line of this. As you can see, here we have it. That is our line. And out of this line, we can actually create a vector because we have an option to create it by 2 points. So we can grab the start point and end point of our line. And again, when you're dealing with geometry, try to kind of investigate what properties, what information it contains. So our line contains start point and it has a point, has end point and the information relative to the point. It has direction, right? Your line has direction. Actually, we can just pick the direction of this. Right, so let's kind of even see this part. So we can go to curves, line, and here in the information we have the direction, and that will be the same as going and picking up the start point and end point. Actually, also wanted to show you how you can grab these properties that go L, for example, start point. There's just a quick way of doing this and an easy way of doing this. For example, because our curve contains start point, we're going to be talking about hierarchy of geometry, so I want to actually cover this in another video. But what does it mean that here we can go, or even so it's going to be easier. I just want to show you that you can do like this. For example, you can go L endpoint. So L here is the variable, is like the variable that you pass from here, and start point is the property. So you can go like start point, end point, and now you will see that the vectors are totally the same, as you can see. So the vectors of the line is totally the same, and the length is actually the same. Or you could have done like this: curve dot start point, curve dot end point, or go point at parameter. It doesn't matter actually, like this, and you could have done it that way. That would be the same. But now we're gonna stick that from the line we can get the direction. So now let's visualize it. So what I want to do right now is to actually hide this. Let's turn on the preview of this. Even if my line, let's even so you can understand it better. If my line was there, and I don't wanna, let's gonna turn on the preview. As you can see, my line is somewhere, okay, I think, okay, let's gonna see if we can see that. Yeah, it's somewhere over here, right? So it's not actually where we want it to be, but because it's not going from the center of the coordinate. But when we get the direction, and let's kind of display the direction. So here I'm gonna go with the vector. So I'm gonna pass, for the time being, I'm gonna just delete it. I don't need it anymore. So I'm gonna pass a vector here. I'm gonna hold the control key to pass it uh, to multiple nodes. And now we have visualized it. So let's kind of click on it. Let's enable background and let's zoom to fit. As you can see now where the vector is. So again, the lesson is our vector always starts from the beginning. So let's say it's too big for me. Right now I want to change it because if I even go there and move this by this direction, so that is my direction, that is my vector. Actually, let's kind of I don't even see this because I need to zoom to feed and it's going to be really difficult for us to visualize it because that is going to be somewhere from here. So it's not that easy to see that part. The first part, the first option is to simply go and change it to make really small. So let's go here. Oops. And see where that was moved. Actually, it's better to just select the geometry and kind of I just don't want to kind of move that close. As you can see, what happened is that here we have this vector and we moved it here because the beginning of this was here, right? Again, it doesn't matter. It can be even here. So if I were to go and change the origin of our sphere to 12, it's gonna move there because it doesn't matter, right? It just goes and that is the vector that it should move to, and that kind of moves along this vector. So I can change the length here, but it's silly to do this with line. But eventually we have some vector and we want to change its length. What we can do, under abstract, under vector, we have an option to normalize it. So what we can do is that grab this vector, okay, it's line, it's not a vector, we just want to visualize it. So now, as you can see, the length will be just 1. So out of this vector that is represented like that, we can get the one where its length equals to 1. So if I go to direction right now, it's going to be 1 to this direction. And if I want to change its length, we already know about scale. So we go vector and specify whatever scale you want to have here, like 10. And now if we connect it to the direction, it will be to 10. So let's kind of display it so you can actually see what we're working with here and here. That is the representation of this vector. So as you can see, it's not that difficult. The main idea is to understand how this works. So in Revit right now, it's going to be easier for you. So if I want to move this element right over here, behind the scenes, there's going to be a vector like this, but not from here, but actually from the beginning of my coordinate system. And what it will do, it will simply move our element like that. And that is the same what happens with our sphere here. So that is like the basics that you need to understand of vectors, that their information is all about like one point, and that is the end point of the vector, because the start point always goes from the origin of the coordinate system, and the length. And actually, it's pretty logical because we have a point, the start point always here, and the end point, for example, here or here or here, and the length will be just the distance between 2 points. So it's not that big a deal. Now what I want to check is that what is the cross product? Because that can be also quite useful. And cross product, first of all, we analyze what we need to pass here to our um, what we need to pass for this node to work. So here we have two vectors. As you can see, once you hover over them, you can see that you have two vectors there. So to these ports, you need to connect two vectors, and eventually you will get the perpendicular one. So for example, I have this vector that we grabbed from the line. I normalized it, right? So let's kind of, for the time being, this visualization is cool. Right now I'm gonna move it there. But let's say I don't want to scale it right now. Or maybe even let's leave this as that. We can also grab and let's grab some of the basis vectors. So all of these x, y, and z, they kind of represent they represent this, if I go to 3D, they kind of represent these vectors. As you can see, the origin is always the start, and here the end for the x, for example, like the one will be here, for the y, one will be here, for the z, y will be here. It's not that big a deal. So let's say I want to grab the z axis, and I want to create a cross product between two of those. So let's grab these ones, move it there. I don't even want to visualize right now. It's not that important for me. And I want to grab this normalized one, for example, here, or even let's go with the scaled one. So I want to go with the scaled one and to the z-axis one. And now it's kind of really interesting what kind of vector we got, you know. So let's visualize each of them. So here, first of all, again, we can see what we've got from this one, right? This and this. So that is our first vector, right, that we grabbed. Let's even let's copy this. You know, it's better to type this, try this in the code block, but okay. So I'm gonna turn this off, and I'm gonna grab the one with the Z, right? That is the one that we've kind of created here. So I'm gonna grab the length and the vector itself. As you can see, because it's kind of normalized, it's gonna be really small, right? That is the vector. It goes up, right? Up. And now what is really interesting is what we get from the cross. So I'm gonna grab this again. I'm gonna copy it to visualize it. I'm gonna grab the vector, pass it here, and pass it to the direction. As you can see what you get, so you had like two vectors, and now you've got the third one that is perpendicular to both of them. So you've had like this one, then we had like the one that goes up, and we can easily get the perpendicular one, right? So that is the power of this. So for example, if I'm dealing For example, let's kind of move our geometry. For example, right now I've had this scaled towards this side, but if I kind of turn that off, for example, I'm going to move it back right here, and I'm going to rotate it there, move it there, right? As you can see, it was moved from here to here, right? That is the vector. That is the vector for this. So cross product is amazing when you have two vectors and you want to get the perpendicular one. You'll actually see how that can be useful, but just bear that in mind because when we get to the like planes, all of this stuff, and find out the rotation of elements, that can be quite useful because I'm gonna show you the usage of these vectors later on. So this what can give what you can get using a cross product. So even if you have some wacky kind of vector that goes here up, right? So it's not like flat he like here it goes like up. We can easily kind of find out what vector is perpendicular. So that is the usage of the cross product. What else do we have? We also can add vectors. For example, here I have So let's go from here. I have this vector and I have the vector that goes up like here on the Z, right? So what I can do, I can grab this one. So that is the vector. As you can see, that is the one that we grabbed from the line. That is this one. Now it's a bit with this part, it's a little bit messy, but okay. So we are going to grab this vector, so this one, and I want to add this one that goes up to the Z. Let's visualize this again. So it's really important when you're just starting with this, just visualize these vectors. It's kind of vitally important for you to understand it. So what you have right now is, as you can see, you kind of moved it a bit. Because what happened, how we add them is that we had this vector. So we go, okay, I have from here to here. And then you go like, I want to add the z vector, this one, this one. And it goes, okay, I go from here to here. Then I go up. And that will be the end point of my vector. Right? Again, it's like adding just points from here to here, then go up, and that'll be the end point. And now we have something like this. So we can even go here and we can scale it, right? So we can go vector.scale, vector.scale, and we can grab right now, for example, I want to move this to 5 and I want to scale it. I'm not going to visualize this. It's just going to be a little bit, or okay, let's kind of visualize it. So we can grab this part and this part. So now it's gonna a bit longer. So I can connect to this. Okay, let's kind of check what we're adding to. So we have the first vector, and that is the z1. That is the z1. That is, yeah. So now, as you can see, I went from here to here, then add to here, and that'll be the endpoint. And now I have this kind of vector. And right now, even you can actually pick up, for example, even these points. So for these two vectors, so you may have two of these vectors, and you can add by the cross product, you can get the perpendicular one as well. So this is a very powerful thing with vectors. So also, okay, we have something like normalized. I think for you it's vitally important to just understand it, and other stuff you'll get on your way of exploring it more. So here uh, we know about scaling, right? So basically, when we want to change the length, when we want to change the length of a vector, we simply scale it. Also, we have subtract. So basically, it would be the same as this one, but we're just kind of subtracting. So if I go here when we added this, like here, and now I want to visualize this vector. This is what we did. We simply go there and then we kind of move down because we subtracted it. So that can be also quite useful. So now if I move this element, that would be moved from here up to here. Like let just try it on your own and you'll actually get it. It's not that complicated. I'll show you some usages in the next videos. So here we also have something like reverse that will just change the direction. So for example, if I, let's kind of move it there. If I go to vector here, so I reversed this one. So I had this vector and I reverse it, right? Let's visualize it. This is where my vector will go. So as you can see, that was going like, that is now going in the totally, so it was going here. But now we kind of reversed it, right? It goes in the opposite direction. So the one was going here, and this one is going here right now. So also an option that you can use, and that can be quite useful. Also, you can ask whether the vectors are kind of the same, right? So use this tool. As you can see here, you have two inputs for vectors, and by getting two of them here, you'll get whether they're the same or not. Also quite useful sometimes. Just be aware that you have this option. Also, we learn about normalized. right? So basically that would make your length be 1. Also, we have rotate, which also kind of quite cool. So here, just to briefly see what it does. So you have vector, you have axis. So for example, this vector rotate around the axis on some angle, right? So for example, if I grab, let's grab, okay, because we've got a lot of stuff going on here. Let's even go with the simple vector. For example, let's go with the x1. So x1, let's grab the z1 so that it'll be easier for you to grasp. We connect the x vector, so the one that I want to rotate. So if I want to visualize it, again, I simply copy this stuff. It's better to type everything in the code block if you're familiar with this. So what I can do is that right now I have this x vector, right? I'm gonna connect this to length and direction. So that is my, I can also go control I, and that will isolate elements that I select. Yeah, that is gonna be better. So I have this vector and I wanna rotate it around the z axis. So I go rotate around z, let's go to 30°. And now I'm gonna just move it a bit. And I just moved the vector, rotated the vector. So also can be quite useful. So actually we've looked at a lot of stuff. What is left is the dot product, and that is my favorite one. It can do a lot of cool features. It has a lot of cool features, and that is so powerful. So in the next lesson about vectors, I'm gonna show you the real examples of usages of vectors with cross product, with dot product, and a lot of cool stuff. So stay tuned. So that's it for this lesson. I hope you enjoyed it. If you find the content useful, please like this video, subscribe to the channel, and turn on notifications. Thank you for watching and have a nice day.